In the last presentation, we completed racing or race around condition in JK flip-flop. I explained you how our output is changing in this manner that we call as the racing, and racing is definitely not a desired output. We don't use racing in anything. So what we use? We use toggling. And the difference between toggling and racing is that racing is an uncontrolled phenomena, whereas the toggling is controlled. So we are having some ways by which we can have toggling out of the racing condition. The first one that I told you was keeping the clock half time period, that is t by 2, less than the propagation delay of our flip-flop. But let me tell you one thing, that this particular method to overcome the racing is not practical and it is not used. So what we are left with? We are left with the second method, that is our edge triggering, and definitely it is used. And the third one and the most important one is the master slave operation that we are going to discuss in this presentation. And this master slave operation is same as the negative edge triggering. So let me write this important point so that you may remember this thing. The master slave operation is same as negative edge triggered flip-flop. I will explain this thing in one of my presentations. When we are having our clock and a circuit depending upon some outputs, we will see how the negative edge triggered flip-flop is same as our master slave flip-flop. It is a very important point to remember, and it helps some time to solve the multiple choice questions. So keep this thing in your mind. Now let's move to our master slave operation. Here you can see a JK flip-flop. A simple JK flip-flop is here with the feedbacks, and the racing is because of this feedback only. So we have to design something so that we can eliminate the effect of this feedback. So what we are going to do? We have to add another stage. By another stage I mean we have to add another circuit like this. So let's do it. It will be clear in a minute. So I need to remove this feedback. So let's do it first. Okay, now the feedback is removed and we have to add one more stage. So I have already copied it down. Let me paste it. This is our one more stage. Okay, now let us connect the output to the input of the second stage like this. And now let us connect the feedback to the output of this stage. So what we have done, instead of having this input to this gate from here, the output of the first stage, we have connected the feedback to the output of the second stage. So this is an important thing in a master slave flip-flop. There are basically two things you have to remember in master slave flip-flop. The first thing is this feedback, that how to connect the feedback. And the second important thing is the clock. You can see a clock has been given to this stage, and also there is a slot for a clock for this stage. But instead of having the clock directly given to this stage, we will complement it first. So we will add a NOT gate here. And now this is the second important point in the master slave operation. And this circuit we call as the master slave circuit. It can be implemented for SR as well as D flip-flop. There is no problem in doing that, but in this presentation we are going to discuss for JK flip-flop. So what is the effect of complementing the clock? Let's see. For example, if J is 1, K is 1 and clock is high, so what will happen? This first stage, these are actually the two flip-flops. This one is my flip-flop 1, this one is my flip-flop 2, and this flip-flop I call as the master. So let me write it down. This flip-flop I call as the master, and this flip-flop I called as the slave, and because of this thing only they are called as the master slave. Now I will explain you why it is called as master and why it is called as slave. It all depends upon the clock, because when clock is high, this master is operational, but as the clock is complemented and given to the slave will not be operational. It will keep the memory. So we are having our output QM changed, and the output Q remains the same because the clock is low when the clock is high for the master. Similarly, when the clock is low, the clock will high for the slave, and master will not be functional, whereas the slave will be functional, and the output changes. But there is one interesting thing going on, that when this output changes, we are having feedback here, but the clock is low, therefore this master is not operational, so there is no effect of feedback. We have eliminated the effect of feedback and hence the racing. So what actually is happening in this circuit is that instead of output changing continuously from 1 to 0, the output changes once in a clock cycle. This is the advantage of this circuit, and that is called as the toggling. For better understanding, we have to make a clock and we have to see for our outputs QM and Q. So let's make our clock first. The clock is changing as a function of time, and the values for J and K are 1 throughout. Okay, so this is my clock. This is low, this is high, and CLOCK. Now we will see what is the value of QM for this. So this is my QM. I will extend this line so that we can plot our outputs in a correct manner. So let me do it first. Okay, this much will work. Now we will plot QM. When clock is high, it means the master is operational while the slave is not. So when the master is operational, and I assume that QM was low before the clock is high, so as soon as the clock is high, the QM will become high also because it was low earlier. Okay, and for what time it will be high? It will be high for this entire time, because when the clock becomes low, the state will be stored, and the state was high, so it will be stored like this, and again when the clock is high, it will become low like this, and then high. So you can say that for a clock cycle we are having the toggling. Okay, it is high, then it is low. This can be used directly. Now we will try to find out our Q, that is the output of our slave, and let's see what we are having. When the clock is high, it means that the master is operational but the slave is not, because we are complementing the clock. So here I am having a 0. So if 0 was the output previously, I am having a 0 stored till the clock is high, and when the clock is low, 0 here, I am having 1 here. It means the slave is operational, so it will go high and it will remain high until the clock again became low. So low and then high. So this is what we are having as the output of our master and output of our slave, and you can clearly see that we have overcome this racing. The output is not changing continuously from 0 to 1, but it is changing once in a cycle. That's we call as the toggling. So if I write the value for our output when J and K and our clock is high, the output Qn plus 1 will be Qn complement. This we call as the toggling, and it is used in the counters. So I hope you understand now what is master slave operation in JK flip flop. It's a very simple thing. You can also do it for the D flip flop, and this is all for this presentation. In the next presentation we will try to understand the operation of the T flip flop. So see you in the next one.